now that we have 1000 replications of this decision of ordering 200 calendars and the demand being from this probability distribution, okay, we can collect some summary statistics from these replications. Okay, let's give a name for this profit column. Okay, then the average profit is average profit. So that will give you the average. Standard deviation is STDEV dot S. And again for profit. So that's the standard deviation. The minimum profit is min, and the maximum profit is max. Now replications is the count of profit. Okay. Now the standard error, we need standard error for the purpose of developing confidence interval. So let's look at what the confidence interval formula is like. So confidence interval for mean profit for us is x bar plus or minus a z value, this multiple here is the z value from normal distribution, times standard error of x bar. Now standard error of x bar is given by standard deviation divided by square root of n. So this is our standard confidence interval formula from your first stat class. So that's why we need the standard error. Standard error is nothing but standard deviation divided by the square root of n, and n is the replication. So the number of profits we have, that's our n. So this is standard deviation divided by square root of the replications. So that will give us the standard error. Okay. Now if you multiply the standard error by the z value from the normal distribution, when we multiply the standard error by the t value, actually we need to use the t distribution because the standard deviation of the population is unknown, and that will give us the sampling error, and then we can add and subtract the sampling error to the average x bar value, and that will give us the lower and the upper limit of the confidence interval. Suppose we want 95% confidence interval, so we put 95% there. Okay. Then the lookup probabilities, remember our normal distribution function, the norm INV function that gives us the table value, okay, it uses the cumulative probability. So we have to adjust this 95% to a lookup value. Okay. And that lookup value is 1 minus alpha. So when we use the t distribution, the t distribution requires the alpha value, that is the tail values. So you need to do 1 minus that. The t is given by t dot INV dot 2t. So that's our two-tail distribution, and the first item is probability, that is the lookup probability, which is the alpha value, which is that. And the degrees of freedom is n minus 1, which is n is the number of replications minus 1. So that will give us the t table value. Okay. And now we multiply the t table value by the standard error, and that gives us the sampling error or margin of error. Margin of error and sampling error, they both are the same thing. So our estimate for profit is the average, and since this is an estimate, our error, margin of error of estimation is that. So lower limit is the average profit minus the margin of error. Okay. and average profit plus the margin of error. So that will give us a confidence interval. So what this means is that we are 95% confident that the profit we will make if we order 200 calendars will be between 173.52 and 214.48 dollars. So that's what this tells us. Of course, once you enter, the limits will change slightly because of the randomness in the demand. So you get a very good estimate of what the range of profits will be most of the time, 95% of the time. And this gives us much more reliable answers for our questions than a deterministic model where we simply assume that the demand is going to be fixed at the average value of 200. So this is much more useful, much more realistic model estimates of the profit.